Hello folks, we are once again back with this next video of this exercise 7.2. In the last video we completed till problem number 32 I suppose. So now we are going to take the problem number 33, which is like the problem number 32. In the problem number 32 we had the question like 1 over 1 plus cot x, and this is going to be just like that but slight change. It is 1 over 1 minus tan x. So let's see how to do this. The 33rd question says that it is integral of dx over 1 minus tan x. So we are going to see how we can do this 1 minus tan x. So as we did in the previous question, because there is nothing that we can substitute and get the answer, so in order to get some more terms, let's try to convert the sine in terms of tan in terms of sine over cos, and let's see how that is going to work. So that's going to be our work now. Let's call this as sine x over cos x, and then obviously we have to equalize this because otherwise we are not able to work with it at all. So let's make this cos x, and like that we are going to get this as dx over cos x minus sin x over cos x. Now, division by a fraction is multiplication by a reciprocal. We know it. So, therefore, this can become cos x dx over cos x minus sin x. Because when we divide, it is multiplying by the reciprocal, and that way we get this. Now, for our convenience, let's try to multiply and divide 2. So that this 2 cos x we can work with and try to see how we can do the substitution. All this stage we are not able to substitute anything to get anything, like because it is cos x minus sin x, that too in the denominator. So that is not going to help us to get anything. So that is why we are introducing the 2 multiplying and dividing by 2, so that we don't change the value. At the same time that 2 comes up, and this 2 is going to help us to restructure the problem and try to get the derivative. Now, in order to get this solved, this 2 cos x, instead of writing this 2 cos x, we can write it as cos x minus sin x plus cos x plus sin x. Yeah, because sin x plus sin x minus sin x will cancel. Cos x plus cos x will become 2 cos x. So we are done with that. Over cos x minus sin x dx. Now when we further restructure this, this will become it is as good as writing cos x minus sin x over cos x. Like denominator you can like distribute amongst both the terms. You know, you can call this as first term, call this as second term, and we can distribute the numerator amongst both the terms, the denominator amongst both the terms. Exactly what we did last time. Actually in the previous question also we did that same thing. So that same thing we are doing here. It is cos x plus sin x. There is a common dx here over cos x minus sin x. We are distributing the denominator to both the numerators separately for our convenience. Now, this is like writing half times. Now, this will be just 1 because they can cancel each other, plus this is cos x. We can break the integral. Okay, half let it be outside, and let this be cos x plus sin x over cos x minus sin x dx. We call the integral in 2 parts. Now, integral of 1 dx we know is dx, but here we can go in for a substitution. How? Let's call this as u. Let u be cos x minus sin x. So what is our derivative? Du over dx. Du over dx, for cos x the derivative is minus sin x, and for sin x the derivative is cos x. So actually it's like writing minus of sin x plus cos x when you take the minus common, since we require the sin x plus cos x over there dx. So let's push the negative sign here and call this as sin x plus cos x dx. So all our work is going to be with the focus on what you require. So we'll keep an eye there, and that's how we're going to get the derivative. So this is how it's coming. So you have now half times outside integral of 1 dx plus, now this integral is changing, sin x plus cos x dx is going to become minus du, and the denominator is going to be u. So this, when you write it, this integral is x, and minus sign can go out, and we all know that this is going to be log modulus u plus c. So u we need to revert back. So it is x minus log modulus u for us is cos x minus sin x plus. That's about it. So that's our problem number 33, very identical to the problem number 32 that we did. So once that is over, let's quickly go to the problem number 34, which also appears to be a little lengthy. I don't know. Let's see when we work out how it is going to come up. It is root. Oh yeah, this is a problem. Yeah, root of tan x over sin x. That also is not so comfortable. I is root of tan x dx, and here it is sin x cos x. So apparently no direct substitution is going to help you. Like you put u as tan x, we cannot get away with the sin and cos, or you substitute sin x, or you substitute cos x. No apparent substitution is going to work. Okay, to start with, let's divide both the numerator and denominator by cos squared x. Let's see how that is going to work. So we are going to divide both the numerator and denominator by cos squared x. When you divide both the numerator and denominator, that's allowed. Okay. So in the numerator, it will be root tan x 6 squared x. 1 over cos x is 6 squared x dx. And denominator, one of the cos can cancel, and you are left with 1 cos x. So sin x over cos x, tan x. Now root tan x and tan x, that will make it root tan x in the denominator, because we know that this is going to be root tan x times root tan x, isn't it? That's how it is. So that can cancel, and you will get here 6 squared x dx over root tan x. Yeah, because one of the root tan x's can cancel, and therefore you are left with that 1 root tan x. Okay, now this is simple and good, because you can call u as tan x, and then you can work it out. So that important thing of dividing by cos squared x is that crux of the matter there. That got prompted because tan is there, so somewhere sec squared should be there. With that idea, that step was taken. All right, and it has worked well. So now let's do the substitution. Let u be tan x. So we know that du over dx is going to be 6 squared x. So du is going to be 6 squared x dx. So what is I now? I is becoming du over root u. And du over root u we all know is 2 root u plus c. So let's revert back. 2 root u, what is u for us? Tan x. 2 root tan x plus c. This is our problem number 34. 2 root tan x plus c. So simple. The answer is so simple, but then the working, that right substitution is important. Otherwise it is like a whirlwind. You will be keeping on thinking what to do, and you wouldn't know how to do it. So at the right time, because that root tan was there, it is there in your mind that something has to be done with the tan, for which sec squared has to be there, and that's how we divided by cos squared, got the answer. That's all for this video. Maybe the next problems we can take in the next video. Thank you.